Nice to meet you. I'm Khudash Ruktai, and we are going to revise structural isomerism for AS organic chemistry students. Let's talk about it. So I'm going to tell you the chain isomer. First of all, whenever you are going to draw the chain isomers, you will concentrate on these number. For example, there is methane. There is only one carbon, so it's having only one structure. There is no other possible isomer for methane. In case 2 carbon, let's suppose it is C2, uh, let's suppose H5Cl, let's suppose. So because of carbon chain, because of chain isomer, there is no other isomer, there is only one this compound, there is only one isomer. If I'm, let's suppose, having C3H7Cl or any other compound, any other, derivative of hydrocarbon, there may be Cl, there may be OH, there may be Br, there may be NH2 and so on. But only one structure is possible because of the carbon chain. So only one chain isomer is possible. But if your molecule is having 4 carbon atom, C4H10, that is a simple alkane, although it's a simple alkane, so because of this carbon, there are 2 chain isomers. There are 2 chain isomer, 2 possible isomers are there. Same is the case if there are 5 carbon atoms, then there are 3 possible isomer. This is the Hizar rule. This is my own rule, and you have to get it in your mind. First of all, whenever you are going to draw, whenever you are supposed to draw the isomers. So if there are 5 carbons, let's suppose C5H12 is pentane, there are 3 different chain isomers. There are 3 different chain isomers. If there are 6 carbon atom, carbon number is equal to 6 in your molecular formula, then there are 5 isomers. I mean, if let's suppose the simplest one I'm going to write over here, simplest C6H14, there are 5 different possible isomers just because of chain. Just because of chain, not because of position of functional group. So first step is step number 1. This is called step number 1. You will draw these chain isomers. You will draw these chain isomer first. Then in second position, on second stage, you will check the position isomers if there is any functional group present in the molecule. And if they are asking to draw the functional group isomer, then you will draw it. Where you can draw the functional group isomers, you can draw it when alkene is over here, the carbon-carbon double bond is over here. So its isomer is possible, that is called cyclic isomer. So these two are said to be basically generally functional group isomer, you can say it. The next thing is acid versus ester. They can be functional group isomers to each other. The next thing is aldehyde and ketone. Aldehyde versus ketone, they may show functional group isomers. So basically, almost as far as your level is concerned, your syllabus is concerned, almost maximum, I think, if I'm not wrong, yes, if I'm not wrong, as far as my memory is concerned at the moment, only 3 these functional group can be asked as a functional group isomerism. Sorry. But rest of the all isomer will be either the chain isomers or they will be the position isomers. So this is a theme. I'm going to solve an example. Let's see over here. First of all, I'm going to draw example number 1, I'm supposed to draw all the isomers, all structural isomer. Up till now we have, counted, or we have concerned with the structural isomer. So here the formula is C4H9 and OH. What is the functional group of this isomer? Can you design, can you define, can you diagnose the functional group isomer? Which one? functional group is over here. I mean, not functional group isomer. Which one is a functional group in this molecule? Please let me know. Overall, you can write this formula C4H10O. So from this formula, you can assess the nature of functional group. Yes. Let's see what is the general formula. This formula, this portion is going to obey the formula of alkane. What is the general formula of alkane? General formula of alkane is CnH2n plus 2. This one. This is the general formula of alkane, right? If general formula of alkane and there is one more oxygen, so this whole formula belongs to alcohol. This is a general formula of alcohol. So this is 4 carbon alcohol. Got it? So the first thing is to diagnose, to see, to check the nature of functional group. Which type of functional group is over here? Now, the next step start. Now I'm going to draw the isomerism. How many carbons are there? Yes, 4. So how many different possible isomer could be there? Because of a chain, 2, shabash, good boy. I am going to write the simple carbon chain. All carbons are lying in the same line, longest chain, and so on. The second one is chain isomer will be, that is having one less carbon in the longest chain, and the fourth one carbon will be acting as a branch. So there are the 2 possible chain isomer when carbon is equal to 4. When total carbon is equal to 4, there are only these 2 possible isomers. Now that's all about chain isomerism. Now I am going to switch towards position isomers. Now the next step starts now. These 2 are the chain isomers. Now this is time to check the position isomers. I'm starting from the first line. Let's suppose if I'm putting OH over here, I'm not going to write H. I'm just for the sake of, shortcut, or for less time consumption, you can say. So what is the name of this compound? If OH is over here and there is a longest chain of 4 carbon atom, there is no branch. What is its name? Let me know. No. Good boy. Shabash. It's a bute in 1-ol. Correct. Got it? If let's suppose now the OH position is over here. What will be its name? Good boy. Butane 2-ol. If I'm putting OH this time over here, what will be the answer? Yes, correct. Good boy. It will be the same. So I'm not allowed to write another similar one. It will be the same. If I'm putting OH over here, again it will be the same, right? So because of this state 4 carbon longest chain, only 2 isomers are possible. One is said to be butane 1-ol, and another one is said to be butane 2-ol. There is no gap between the name. Accidentally, you can say it has been written over here. So now come toward the lower structure, lower chain. These 3 carbons are exactly same carbon. These all are CH3 and they are similar CH3. They all are bonding to the same carbon. So they are similar, specifically. If the different groups are attached, you can see that 3 carbons are attaching to the central carbon. So these 3 carbons are same carbon, similar carbon. There is no need to check them alternatively or one by one. Just check one of them. What is its name? If I'm writing OH over here, or if I'm putting OH over here, the name will be the same. What is its name? This is the longest chain and this is the branch. and numbering will be started from this one, and that is more closer to OH group. So it will be 2 methyl, yes, 2 methyl pro in single bond 1 ol. So its name is 2-methyl propane 1-ol. Nomenclature is very important whenever you are going to decide, going to check the nature of isomerism. The next thing is, if I mean, putting OH at this carbon atom, what will be its name? Good boy. 2-methyl propane 2-ol. If you do more practice, you will be super fine in this one, but you need to, I mean, you are needed a lot of practice as far as my opinion is concerned. It's like a mathematics, and you will have to do more practice, much more practice, not more, much more. Yes, exam question are very much pretty similar like that I mean told you. For example, C4H9OH, and they are asking how many total structural isomers are there. Now you have drawn this structural isomer. How many structural isomers are there? 4 structural isomers are there. This is the only shortcut way to diagnose the structural isomers and then स्टीरियो स्टीरियो आइसोमरिज्म में मैं आपको एक खिजर रूल बताऊंगा, लेकिन स्ट्रक्चरल आइसोमरिज्म में देयर इज नो खिजर रूल. इससे ज़्यादा शॉर्टकट कोई रूल नहीं है. वो मैंने जो बताना था बता दिया यहाँ पे, आपने इसको चेक करना है. सो वेन एवर यू आर गोइंग टू ड्रॉ द आइसोमर्स, there is only one way out to draw their structures for the confirmation, write their names, and check how many different names you have written over there. So these are the total number of possible isomers and so on. Now let's see over here, come towards another example. This is not very much difficult example as far as my opinion is concerned, but I'm going to decrease the number of carbon atom. This time I'm taking C3 and H5Cl. Right. So the first thing is you will detect, you will check what type of functional group is this one. This is a halo. Generally it seems to be halo alkene, but it is not alkene. Let put halogens, Cl is equal to hydrogen. Then what will be its formula? Its formula will be C3H6. So C3H6 is a general formula of alkene, right? It is having one carbon-carbon double bond. You will have to check. I mean, the similar question will be asked. So this is an alkene and there is only one Cl. Now again I'm going to start from the chain isomerism. How many chain isomerism are possible if the 3 carbon atoms are over here? One only. Good boy. So I'm going to write 3 carbons, 2 and double bond 3. Boom. That's all. Now the next term is basically Cl. Let's suppose I'm putting Cl over here. What is its name? Its name will be 1-chloro propene or prop-1-ene. If I'm putting Cl over here, then its name will be 2-chloro. Names are very important whenever you are going to write the nature of isomerism, structure of isomerism, counting of isomerism. 2-chloro propene. If I'm putting this Cl over here, what will be its name? Mr. Tahar Rafiq, please let me know. Numbering will be started from the double bond. This carbon again will be carbon number 1, this is carbon number 2, and this carbon is carbon number 3. So whenever you are going to mark numbering and Cl is present and double bond is present, then double bond will get preference with respect to numbering. So now its position is equal to 3 and it is 3-chloro pro 1-ene, or there is no need to write 1-ene. So 3 different compounds can be written with respect to this molecule. So it is having overall three isomers. Three isomers. Now come towards another question, another example. I'm going to write another example, that is C5H11Cl. Again, you will have to check that which one is a functional group, and the second one, is there any sort of double bond or not. Then you will start to write, the different possible chains, different possible chain isomers. Then you will do position isomers. So first of all, there is a haloalkane. Cl is present over here, and it is not having this time any carbon-carbon double bond. It is not having any carbon-carbon double bond. I told you the shortcut way, that let's suppose this Cl is equal to hydrogen. So one Cl, I'm putting one hydrogen. C5H12 mean this is obeying the formula of alkane. So there is no carbon-carbon double bond. Now let's see what is the total chain isomers. If the carbon number is equal to 5, then how many chain isomers could be there? 3. Good. So first of all, it's your duty to draw first these three isomers. What are the isomers? Put all carbon in a straight line. This is a simple, very simple one isomer. Then make one carbon shorter, make it 4 carbon chain, and draw a branch. I'm going to make one branch over here. I have eliminated this carbon, I have deleted this carbon. Now the carbon chain, longest chain, is equal to 4. Initially it was 5, so it is the second one. What is the third one? The possible, again, I am going to short one more carbon. There is one more carbon less in this compound, and the both other carbon, 5 carbons in total, other 2 carbons are in the branch. So these are generally 3 chain structure isomers. If the carbon is equal to 5, then these are 3 chain structure isomer. Now, step 2 started. There is a turn for the step number 2. Then you will mark Cl over here. Let's suppose I'm writing Cl over here. What is its name? This time I'm going to write name over here. What will be its name? Please let me know. नेम लिखना आपको आना चाहिए, ये बहुत जरूरी. Chloro, yes, pent, good, pentane, all carbon, single bond, 1 chloropentane. If I'm putting Cl over here, then what? Good boy, 2 chloropentane. If I'm putting Cl over here, good, it will be 3 chloropentane. If I'm putting Cl over here, okay, we already have it, so yes, good. And it is a 1 chloro, again we are having 1 chloro. So because of this longest chain, only 3 different names can be written. Only 3 different possible isomers are there. Now we should switch toward the second category. In this one, again I told you, and these 2 carbon are attaching with the same carbon atom, these 2 methyl group, so they are same, they are one and the same. There is no need to check them turn by turn. I am just checking once. I am putting Cl over here. What is its name? And I am going to write the name on next side. Yes, please, what is its name? Good boy. 2 methyl 1 chloro, पहले लिखेंगे हम 1 chloro, because alphabetically Cl comes first then M, so 1 chloro dash 2 methyl and butane. Good boy, small b u t a n e. Good. If I'm writing, but basically there are basically 2 branches. This functional group is also written as a branch. Now I'm going to write the 2 branches, and one branch start from C Other one is going to start from M. So which one comes alphabetically first? C. That's why, irrespective of their position, irrespective of their numbers, you will see their names. Which one is coming first? So you will write it first. Got it? Okay. If the seal is over here, what is its name? Good boy. 2-chloro, 2-chloro dash 2-methyl butane. If I'm putting Cl over here, now from where to mark numbering? Yes, it's important. This Cl is now near to this edge, this corner, this end. So this will be carbon number 1 and numbering will move like that. So it is again 2-chloro, 2-chloro dash, what is methyl? Three methyl, correct. 3-methyl butane, yes. Now the last one option is if I'm putting Cl over here, then what will be the name? It will be obviously 1-chloro 3-methyl 3-methyl butane. Good boy. So because of this longest chain, one, two, tick लगा रहा हूं मैं, 2, 3, 4, 4 different possible compounds are there. Because of the first chain, there was 3 isomers, 3 name. Because of this longest chain, there are basically 4 isomers. Now it's turn for the last one. It's turn for this one, for the last one. I mean this one. What about this one? Let's see. How many different isomer can we write it over here? You know that all these 4 carbons are these all 4 carbons are same, correct? They all are same, they all are CH3, they all are meeting with the same carbon. So just write on the one Cl. And here you cannot write the Cl because it is having no hydrogen. When wherever you can place the functional group where there is hydrogen. So it's actually it was CH3, now it's CH2, it is CH3, it was CH3, it was CH3, and there is no H. So you cannot put Cl over here. So you can either mark Cl over here, over here, over here, over here, but it will be the same name. So just check it one. Only one isomer is possible. There is no need to write the name. However, I'm going to write the name. What will be its name? Let's see over here. What is its name? Its name will be, again, this is the carbon number 1, carbon number 2, and this is carbon number 3. So there are 2 branches at 2 position. So 2 comma 2 dash dimethyl and 1-chloro. I forget to write 1-chloro first. First we will write 1-chloro because C comes first. So I'm writing it over here, and it's 1-chloro dash hyphen 2,2-dimethyl. How many carbons in the longest chain? 3 carbon. It means prop. All carbon are single bond propane. So this is the name. So how many total isomers are there overall? 3, 4, and 1. So 8 isomers are there. Just structural isomers. We didn't count any sort of stereoisomer yet. This is about how to check, how to draw. So if your formula is having 5 carbon atom and 1 Cl, then the structural isomer is equal to 8. But this is hard to memorize, to cram, रटा नहीं मार सकते आप इसको, पता नहीं वो क्या पूछेगा वहाँ पर. So that's why you must know how to draw their isomers. First of all, you will draw the chain isomers, then you will draw their position isomers, there is no need to draw the functional group isomer until unless they are asking to you. हाँ, जैसे मैंने आपको बताया है initially, if you are having acid and ester, you may draw. You are having aldehyde or ketones collective formula unit, or the collective molecular formula that may be an aldehyde, that may be a ketone, then you must draw, you should draw, I mean. And if he is asking to draw the cyclic as well, then double bond molecule can be have a cyclic isomer. I mean, any molecule, if it is having three or more than three carbon atom, and it can be written as in a cyclic way with the same molecular formula. I'm going to show it over here. For example, I'm having once again Ci3, CH2 double bond, CH2, not CH2, is CH. So this is basically a propene that is having 3 carbons and 6 hydrogen. I can draw its cyclic formula like that. Yes. Now they both are having same molecular formula C3H6, but they are not the same or similar compound. They are different compound. It is basically an alkene. It is cycloalkane. So they are said to be isomers. They are having different structures. They are having different names, but they are having same molecular formula. So they can be known as isomers. So this is all about the story. I mean, whatever is asked, and I mean, I don't think so they are going to exceed the carbon chain from 6 carbon atom. This is the maximum limit. Usually they are asked till 5 carbon atom. Usually, normally, 99% you can say. But even though it may ask, it maximum it can ask up to the 6 carbon atom, and that is all about this one. If you are going to follow this scheme, hopefully, inshallah, you will get the full marks. तमाम क्वेश्चन आपके बिल्कुल ठीक होंगे. आपने स्ट्रिक्टली फॉलो करना है इसी अरेंजमेंट को. एंड आई मीन that is the technical one, that is a highly conceptual one, and we cannot claim, as I told you, हम इसको memorize नहीं या रटा नहीं लगा सकते हैं. तो but it is very necessary. I mean, we are having no option to skip this topic. The reason is, the basic thing is nomenclature. Nomenclature is the mother of organic compound. Whenever you are going to see the question, you are going to visualize the question, you are going to read the question, the first thing is its nomenclature. अगर आपको nomenclature आता है तो आप पहचान लेंगे. उसका नाम लिखा हुआ है. Usually there is the namings are given. Structure given नहीं होता, नाम लिखा होता है. You can assess its haloalkane, its acid, its double bond, and its structure is like that. Its branch structure, it has state chain structure. So many chemical and physical properties can be predicted after knowing the name of that compound.